Hello, this is OCP Future Technology Symposium. I would like to welcome you to the Industry Investment Panel. My name is Leslie Dimit and I'm going to be your panel moderator. I'm Innovation Engineer at the R&D Department of TUSA and also a Program Chair at the OCP Future Technology Symposium. And today, our panelists are Rick from Microsoft, James from Facebook, and Yuri from Intel. And before we move to our discussion, I would like to give you a brief introduction and a background information on the OCP Future Technology Symposium. So in 2019, OCP Foundation has started to work on creation of a platform where people from academia, startups, technology, and investor communities can come together to collaborate towards solving the future problems and challenges that we face in the data center infrastructure and in our industry around the world. So we call this initiative as the OCP Future Technology Symposium, or simply Symposium. And the reason why we decided to create the OCP Symposium is to serve as a forward-looking funnel for new technologies, to help and scale innovative technologies. But also we wanted to create a space where talented people, both from the academia, industry, and startups communities, can come together and work with the OCP community. Despite the fact that we are quite innovation focused, we also have tangible objectives, and we want to create technologies that can be adopted in our industry in the next couple of years. So now I suggest that we move to the panel discussion. And I would like to start with Rick, who is the IE Business Development Head at the M12 Microsoft Venture Fund. Rick, could you please tell us a little bit about yourself and about your work at M12?
Sure. Hello, James, Lesia, and Yuri. Pleasure to be here today. And I am with Microsoft's Venture Fund, M12. You can think of it as a corporate-owned fund where we invest in startups that are either directly related or maybe tangentially related to Microsoft's business in cybersecurity, enterprise software, identity management, and now increasingly AI and computing, right? That's probably the largest space when we think of AI and computing, that covers both software, it covers tools and frameworks, it covers algorithms as well as computational hardware. So the things that come down to kind of the OCP platform level, it's really also looking at innovative startups, innovative companies that are really trying to change how AI workloads are computed, how they're deployed across vast networks of processors where you may have thousands of processors all running. It almost becomes a HPC, high performance computing problem, but for AI. So hopefully we'll get a chance to talk today about that thesis coming out of M12, where we're really looking at innovation that can drive energy consumption down by 10 to 1, maybe even 100 to 1 in the data center for AI computation. And as a nice side effect, the carbon dioxide emissions of either scope 2 and scope 3 CO2 emissions from the use of the AI algorithms, from generation of the energy to drive the data centers, as well as consumers on the far end that may be consuming these products as well. Thanks.
Thank you, Rick.
Lesia.
Now I would like to present you James, who is the Director of Optical Hardware Engineering at Facebook. James, can you tell us a little bit about your work and about yourself and what do you do at Facebook?
Sure, Lisa. I work in Facebook's infrastructure group in the hardware engineering team. And the hardware engineering team creates compute, network, and hardware, compute, storage, and network hardware that are used in Facebook's data centers. And my particular focus is on network hardware and specifically optical technologies. Prior to Facebook, I worked at a number of companies that focused on optical interconnect, new product development, and my current focus and interests are on highly integrated optics for data center applications. And the work there is really focusing on getting the power down so that as our capacity scales over the next 5 years by about a factor of 8, we can keep the power consumption per network switch flat. So that's the real challenge that my team is facing right now.
Thank you, James. We also have our guest from Intel, Yuri. Yuri is a connectivity group CTO at Intel. Yuri, tell us a little bit more about yourself and your work.
Well, thank you, and good morning. So my name is Yuri Cummings. I'm the CTO of the connectivity group at Intel. Connectivity group is a part of the overall data center platforms group, or DPG, that makes the Xeon CPUs at Intel. And what we do is we focus on, essentially we work at the intercept between networking and compute. And we have 3 business units in our group. We have the Silicon Photonics group, which is making optics, which comes from a novel silicon manufacturing process. We have the Ethernet products group, which is making NIC devices, all sorts of different Ethernet NIC devices. And we recently acquired the Barefoot Networking group, which makes Ethernet switches. So what we're really looking at is doing all of the scope of interconnect hardware and software that interconnects the data center, and to some extent also goes sort of beyond the data center into the core networks or the edge networks, and sometimes user devices like an automotive and whatnot. And so my background is as CTO. I look at emerging technology trends. We do technology problem solving, and we develop architecture for our new products. Before working at Intel Corporation, I was a founder of a startup called Fulcrum Microsystems that built Ethernet switches about a decade ago.
Thank you, Yuri. Wow, I think we have a great profiles here with a lot of technical background and skills. This is amazing. And as I said, OCP Symposium is a lot about future technologies. So now I would like to ask you the following question. How does your organization currently identify new technologies for development? Rick, can you please start and tell us how do you do that at Microsoft?
Sure. We have a luxurious position as M12 of both kind of being part of Microsoft, but we're also an outsider group. And in that sort of scenario, my role especially, and the rest of our team, is really looking at signals or trends that might be happening outside in the industry and bringing those in to help influence product strategy, research, what have you. And as well, we're looking for our product teams that may be needing to either go out to partner or to find startups and partners with whom we can either partner, invest, or acquire. And so part of the sourcing of new technologies is really that signal analysis, if you will. And some of the themes that I've been focused on, really looking at alignment with Microsoft Corp and with the outside industry, is really around energy, AI efficiency, which is sort of all really the same thing in a way, and then even the networking stack all the way to the software stack. So if you think, I have this picture in my head of when you want to create AI algorithms or any high performance computing workload, you have to start with kind of the software layer first, and there are disruptions happening in that. There are disruptions happening in how those get spread across data centers at some cost to the user. Maybe they're willing to pay more money to do faster things, or pay less money but wait for it. And that kind of distribution is important all the way down to the hardware layers and even algorithmic disruptions. So once you break things down sort of into layers of how you have to do the work, it's pretty easy to identify the technologies that have to be worked on. Same thing happens in cybersecurity, where we can apply AI to cybersecurity. Each of these things break down fundamentally to new technologies that we can source.
Yuri, and what about Intel? How do you do that at Intel?
Intel's a pretty big place. We have a corporate investment arm similar to Rick's called ICAP. So I'd like to kind of look at within the connectivity group, how do we think about this? And what we tend to do is look at, okay, what are the trends for computing? In some cases that goes out 10 years, in some cases it's more like 3 to 5 years. Computing is highly dynamic space. There's all sorts of new system level architectures coming out, new concepts within computing, and new form factors. So maybe, you know, if they're big processors, or maybe they're artificial intelligence processors, or GPUs, for instance. There's all sorts of, you know, different trends in computing that are going to create new problems in the connectivity space. So we like to really understand those trends and understand where the market is going, or predict where the market is going. And then we, you know, try and develop a thesis around, you know, what are the new needs that our customers and users are going to, you know, develop within computing infrastructure, and you know, how does that impact connectivity? And we see that across our domains in terms of optics, NICs, and switches. There's a significant amount of new, you know, requirements coming out on the horizon. Sometimes it's more energy efficiency, sometimes it's more bandwidth or bandwidth density, and often it's, you know, different types of communications primitives, and or there's a migration of where a workload is being computed from, you know, the server itself, or sometimes it's more like in a smart NIC or computational device, which is more part of the network. So we look at all those things. We engage with academic community and with industry research, either with our own labs or with our peer group laboratories, with ecosystems, customer ecosystems, as well as, you know, organizations like OCP or ONF, or, you know, standards bodies. The Linux community is really important to us, so we do a lot of work with software. And then, you know, as you know, we really see, you know, hey, here's where we have to be 3 to 5 years to sort of maintain that computing CAGR and continue to deliver the TCO in the data center related to the connectivity, you know, devices. Then we go drive products and go through the technical readiness and whatnot. So this whole process from, in fact, I think most of the interesting work is really 3 to 5 years, 2 years out, you know, what's really going to, and then trying to sort of get people to, you know, recognize what some of these new problem spaces, you know, are, because sometimes it takes a couple of years to really figure out what the right solution to a problem is.
And also convince your team probably to adopt this solution if it's a really innovative one.
Yes.
Yes, I would like also to hear from James. How do you do that at Facebook?
I think the challenge in our end is a bit different. We deploy and operate a very large network. So understanding the network needs, looking out several generations, is something we have a unique position and perspective for. So identifying the technology needs is not the trick. The issue on our side is the hardware that goes into our data center gets deployed at very high volumes. And new technologies typically take years to mature to a state where they're ready to be used at that kind of scale. And so the real challenge for us is, you know, this gap where you've identified a technology that's going to be needed in a 5-year horizon, and getting momentum from the ecosystem to work on those technologies, knowing that they're going to take years to mature, but that they're years away from productization. That's really the challenge we face, is how do we get interest to work on these problems? And sometimes that's easier in academia where you can fund. For startups, this is a real challenge, getting them to work on technology problems that are 5 years out. And for larger companies that have deeper pockets and longer time horizons, sometimes that's easier to do. But to answer your questions in short, our challenge isn't identifying new technologies. It's when we do identify those new technologies, how do we get that are 5 years out? How do we get focused to bring those to maturation in the time to intersect our need?
This is a really great question, and probably maybe with Symposium we'll be able to answer this question together. So my next question will be again to you, James. I know that Facebook is one of the largest contributors of the open hardware to the OCP community, but I also know that the company has a lot of patents. So for example, in the period between 2019 and 20, you received at least 19 patents in diverse data center solutions. So how efficient is this strategy to protect your IP rights in the modern IT business, and how it can coexist with the open source model where we are right now?
Yeah, I would argue those 19 patents is an incredibly small number of patents for the area we work in and the scale that we deploy IT equipment. And, you know, Facebook's infrastructure IP strategy, it's pretty well aligned with an open source model. And a lot of time these patents, they're really defensive measures. It's when we see a need that's 5 years out. How do you make sure that technology can remain open at a time when it starts to come to scale so that it's not locked down by a single entity?
Okay, thank you. So my next question will go to Rick. I know that M12 invests in startups that work on areas such as cybersecurity, artificial intelligence, machine learning, productivity, and also invest in next generation of cloud infrastructure. So I'm wondering, how can startups or researchers benefit from the access to the Microsoft resources and ecosystem?
Sure. This is like the $1 million question I think every startup asks me. It's like, how do we sell to Microsoft or any of the other large whale cloud partners or cloud companies? But bringing it to practical nature, I think our fund hears from maybe, I wouldn't be surprised if it's thousands of startups every year, and not all of them make it to investment from M12. But if you make it through that gauntlet and become a portfolio company of M12, then part of the benefit, if you will, or part of what we really try to do as a venture fund is provide that brokerage between the startup and Microsoft, right? That's really what differentiates us. And I would say of the number of investors that we have, the investment professionals, it's probably weighted 3 to 1, where we actually have what are called portfolio development professionals who actually work with each of our startups. Today we have over 80 portfolio companies in our portfolio, and their role is to really kind of be the conduit and the broker and try to match make, if you will, between Microsoft and the startup. And it's been phenomenally successful, right? So assuming M12 makes the right financial bets and investing in the right companies, then we should normally see alignment between the startup and Microsoft. And then M12's role is to really try to, escort them in, if you will. I don't see that in many other places. I can't say that no one else does that, but I haven't seen it done quite this well anywhere else. And then my role is to try to be at the front end of that pipeline where we're sourcing technologies that might feed into the investment pipeline and create revenue potential in 2 to 5 years, right? So this is that 2 to 5 year horizon that Yuri talked about, right? It's not always a startup today, but it may be an emerging startup or one about to form out of some PhDs or professors. It might be a startup that's been stealth for some time, and to try to feed that into the system as well, and also broker and partner between the startup and Microsoft.
Okay, so before you decide to invest into a startup, what are the 3 features that you look for?
I didn't hear that. What are the 3 features you said?
Or 3 criteria that can help you to make a decision, invest or not.
Yeah, I think every investor has their own, criterion,
Yeah.
but I'll tell you what it's not. It's not that it must be aligned with Microsoft, or even that sort of an exclusion principle is not that they are competitive with Microsoft. If they actually have an amazing product and team in a big market, right? So it's amazing product, great team, big market potential, then those are criteria to invest. And then I would say the 4th one, which makes it a good product, is it's actually an innovative thing that few people can do, either because of the smarts of the team or just they're so far ahead of everyone else. That makes it a good investment.
Yes, that's wonderful. Thank you. And also, I have a question for Yuri. I know that Yuri and your team as well worked a lot on a cloud data center. So tell me a little bit more about next scale of cloud. What is the continued advancement of the cloud technology?
Well, sometimes I think in order to sort of predict where we're going, we sort of need to look at where we've been. And in the past, we used to say, we live in a data center world, which is really a statement around the centralization of compute from an enterprise computing model to a data center computing model, where either the public cloud vendors or other types of cloud vendors really, centralized that compute and made it more efficient. And what we think going forward is we're moving from a data center model to a data-centric model, which sounds like almost a trivial change in words, but what it really means is it's not so much about the computing or IT infrastructure per se, it's about the data. And the amount of data that our society is generating, I mean, even before we all started working online, right? The amount of data we've been generating is in the like hundreds of zettabytes. It's truly an incredible amount of data. So we kind of look at how, in the future, can we derive hardware value from how we move, process, and store data. And really, when you look at all this data, it's kind of like a heap of data. We haven't actually gone that far in terms of really deriving a lot of value from all of the data that society has generated. That's not to say we're not doing a lot of work. It's really that there's a lot more that we could do. So yeah, we move data, we store data, we protect it. You can create content, distribute content, and all that. But if you really look at what we can do in society when the computational infrastructure can really get into all of that data and make great decisions based on that data, and come up with, I don't know, new data based on the data. There's a lot more we can do with computing. And I think that's what we're looking at going forward. It's really, it's not so much about the compute architecture per se. It's really about what can we do, with this digitization of society and all our digital assets. Yeah, so that's where we're going. So yeah, probably more data. I mean, we'll have to probably get past the zetas, if you will. But what does it really mean? I mean, I think what it really means is the types of clouds that people are building and the applications that they're running on it to really enrich people's lives through the processing of data.
Yeah, my additional question to you would be to know, are you doing any research or development already on the energy savings technology?
There's a lot of different ways you can look at saving energy. In some cases, it's going to, looking at an algorithm like artificial intelligence versus high performance computing and saying, hey, I don't need 64-bit floating points. I could do this with 16-bit floating point, or maybe I can even do it with 8-bit or 4-bit or 2-bit or something like that. Another technology that we spend a lot of time looking on is optics, and how do you get the power down for optics more efficient link budgets. Getting the bandwidth up often is how we get the power per bit down. And then integration of optics into more traditional ASIC-like hardware. So optics integrated into switches. We were going to demonstrate at the OFC conference 1.6 terabit integrated switch optics. We wound up backing out of that conference, but because of the current environment. But we made that available for people to look at that demo, on blogs and whatnot. And it's really fascinating when you look at, could I actually combine optical technology and silicon technology? I mean, the computational silicon technology together, and what does that mean, right? And we think, in the future, we can keep getting to improved energy, per instruction, or energy per bit through better integration, as well as the more traditional things like going further along in the Moore's law trajectory.
Thank you, Yuri. Rick, I saw you wanted to add something on this question, so please.
Just follow up on Yuri's point, right? So what he talked about was sort of collapsing network or interconnect, whether it's photonic or electrical, with computation, right? So you can think of this cake, a layer cake, if you will, where network may be in the middle and computation's at the bottom. I agree. And I think there's a third layer, which is the software and algorithms that lay on top of that. And we see the incentives right now for the software to change are a lot less intensive than they could be. So when we talk about the whole energy saving pie, I think the hardware can do great leaps. As we said, there's at least 10-to-1 reduction in energy consumption or total cost of ownership over the lifetime of that hardware. There's a huge amount of savings from the hardware, but now how do we incentivize the folks actually doing the algorithms and the frameworks and software on top? And so that's another initiative that we're looking into is that our AI designers need to come up with more efficient ways than coming up with 100 billion parameter AI models, right, that take weeks to train. There has to be a better way. There are better ways, but now we have to incentivize that industry to look at those. So I think it's those three stacks: software, network, computation.
Yeah, so we need a combination of these three. Thank you, Rick. James, if you want to add something to the discussion on the energy optimization, please, if you have some development in the hardware optical engineering.
Yeah, sure. I mentioned earlier this need over the next 5-year period to about an 8x increase in the capacity of a network switch, and at the same time, a network switch flat. And the reasons for that are multifold. Certainly there are reductions. They're environmentally better. The OpEx is less because you can consume less power. But established data centers are just running into problems with the utility load and the thermal load in some of these network rooms. And so there's some real practical problems that we're running into. And trying to upgrade facilities while running networks is an incredibly disruptive, difficult, and expensive thing to do. So these power reductions, they have a real kind of practical backbone that's driving them. Some of the techniques, my focus is on network hardware, are similar to what Yuri was mentioning. In fact, Facebook has been working with Intel in that area of co-packaged optics, where we bring the optics closer to the switch and use less power on those electrical interconnections between the optics and the switching ASIC. That's one area that we think one of the most powerful things we have, at least from a hardware perspective, to reduce network power consumption.
Yeah. So yeah, we had a slight deviation from our initial question, but we spoke about the energy optimization together with Yuri, James, and Rick. And now I would like to move to our more general question on what are the specific areas of collaboration between researchers and startup and businesses that can bring the most value to our industry. We just spoke about the energy optimization. Are there any other areas? Rick, can you please start?
Yeah, so I think this is really an expansion of James's point, where he talked about disruptive innovation in hardware, software, networking, happen at the research level first. Usually, they may be driven by industry needs, maybe problem statements driven by Facebook, Microsoft, Intel. But it's the researchers, right, that work on those problems for and large that are maybe 5 years out from revenue or impacting your business, right? And it's the startups that are kind of in that, you might call it a valley of death, or kind of this chasm of uncertainty where it's between research and actual applied technology. And James also talked about, hey, there are cool technologies out there, but actually bringing it in and deploying it at scale is just really tough. It's like changing the wheels on a bus as it's driving down the road. I mean, you just have so much inertia built up to stay where you are because it's working. So there's this, kind of the 1 to 2 year horizon. That's normally what Microsoft may focus on first. There's the investment horizon, which may be 2 to 3 years out. And then there's kind of the research pipeline. And I kind of like to, look out at the research pipeline. There are all kinds of crazy ideas, but some of those can filter down into interesting startup opportunities that align with Microsoft. So I think the collaboration is really about partnering with university and PhD, researchers in the right areas. In optics, there are universities all around that are doing some really cool things in nanophotonics, wide spectrum optics, as an example, in AI processing, but they're not ready for production yet. They may become a startup. That's when I get interested, and then we pull them into production over time. So maybe I described a pipeline, if you will, of innovation.
James, can you please continue and tell us about your point of view on the specific areas of collaboration?
Yeah, I think there's a couple areas that are of particular interest for research for data center networks these days. One we've spent some time discussing, which is optical integration in order to save power, and this can run the gamut, but I think the end point is what Yuri was discussing with co-packaged optics, where you move the optics on the same substrate with the switch IC. I think other areas that are ripe for research, if you look at long-haul optical networks and the work in complex modulation schemes that have been productized there, and you contrast that to what's been going on in data centers where there's been little change. Up until very recently, we've been using the most basic module since the very beginning. There's been literally no change. And that's just starting to bend. And I think in the future, that's an area where you're going to see a lot of change come inside the data center, or these more advanced modulation formats that were pioneered in transport coming inside the data center.
Okay, thank you. Yuri, any specific proposals?
Yeah, I definitely agree with what James is saying. I wanted to introduce another topic, though, where I think there's a lot of opportunity, especially when, with academic and research and startups, often that's where, people have really great ideas that can be very impactful years down the road, but there isn't necessarily a lot of money, right? So it's not like we want to go do a really expensive product development cycle. It's like, here's a great idea that might sort of change the way we think about our infrastructure. And one of the areas where I think, there's really been a lot of kind of new ideas, which can be helpful, is in the development of programmable NICs and programmable switches. Mm-hmm. So by programmable, I don't mean like, okay, I'm running software on a CPU. We actually mean that the state machines that are doing what we would normally think of hardware packet processing have become programmable themselves. And so, there's some new languages, for instance, P4, which can be used to define how a packet forwarding device manipulates the headers in a packet and moves the data, from an input to an output. And all that logic can be done at an abstract software layer and then compiled down into the switch or compiled into the NIC. And it can still allow you to run, the networks essentially just as fast as when you had this long ASIC development cycle. And you've also seen similar things with FPGAs, right? The whole concept of an FPGA toolchain, where you get a bit stream that runs on the FPGA, but acts like hardware, in terms of its performance and its power consumption. That's really pretty interesting. And I think there's a lot of opportunities with concepts like that, where people with some interesting idea of new networking algorithms or transports or whatnot, or new security models can say, hey, we can program the network to achieve these new benefits. And it only takes a couple people to go do that if there's the right infrastructure and ecosystem there to support it.
Yeah, if I could follow up on that, because I think you brought up two practical examples, James and Yuri. So again, thinking about the whole system, and again, I'm closest to, say, AI training workloads or HPC. There are really interesting things happening in nanophotonics now, where you talk about taking the optical transmitter, receiver, and putting them in the same substrate or even the same monolithic CMOS chip, and then now that becomes cost-effective, lower energy. There's some really cool things there where people can take a neural net technology, right, that they've used to actually equalize the optical channel with the transmitter, right? So if you get this optimal equalization between your optics in, out, and your fiber, then you can go farther distances. Basically, you reduce your signal to noise ratio. So now neural nets are becoming the filter, if you will, for these optical long haul transmissions. I can see that if it's cheap enough, and if you can actually do photonic computing of neural nets, in the nanophotonic domain, then you've got transceivers that are now disruptively cheap and low energy, right? So there's some interesting research happening in both those directions. And then, the other side of it is, if you think about AI and HPC workloads, I have this pithy quote. It may not be all covering, but it's that in these workloads, the network is the computer in a way, right? Unpack that. So much time is spent for these algorithms just transporting data across the network, and it's making the hardware sort of idle and spin because it's waiting for the network. So now there's some things with barefoot networks or with smart NICs or what have you now, where maybe some of that computation can be done on the fly as it's being transported from one machine to the other, which is a pretty innovative way to do things. Now, today those have to be hand engineered because there's no TensorFlow for network transport, right? But maybe, you can see perhaps in the future, if we're really thinking disruptively distributed, then maybe we'll have that software framework, right? That can put computation in the network and computation at the NIC, et cetera. So, it's amazing opportunity. So I'd like to see that happen.
Thank you. So now we are ready to move to our last question. We spoke about different technologies and we spoke about the challenges of bringing breakthrough technologies to the market. And as I previously mentioned, the objective of OCP is to define these breakthrough technologies and help them bring to the OCP community and to the market. So my last question would be, what would you like to see from the OCP Symposium in the next 2 years? Yuri?
That's a good question. By the way, before I answer, let me say, we think that OCP has just been fantastic. It's had a wonderful impact on the industry, and it's really opened things up quite a bit. And I think a lot of the success so far with OCP has been in hardware. In creating standardized server hardware, in creating one of our favorites for our group is the OCP mezzanine card definition that's used for NICs. And actually, a lot of the OEM-specific infrastructure has actually migrated over to OCP because there's been such a great impact on the industry. There's been a lot of really good sort of, standardization around the management interfaces and basically how you really make that hardware open. But I don't think it can just end at the hardware and at platform layer, because when you look at a system, there can tend to be a bit of a blurry line between software and hardware. And a lot of the innovation, I think, is, we need to go up into the software to really get a lot of the innovation that's available to us in the future. So I would like to see OCP really do the same thing with software that they did with hardware. Now, of course, there's other ecosystems out there like Linux and whatnot that is treating software. So I wouldn't want to see OCP sort of overlap with any of those other ecosystems. But I think there's a special thing that OCP can bring to the table in terms of the software piece or the system level combination of hardware and software. So that's where I'd like to see some more progress over the next couple of years.
Rick?
Well, I must profess I'm new to OCP. I know of OCP and have tracked what's happening. My colleagues at Microsoft are probably better positioned to say what would they like to see next. But I like Yuri's comment, and that is, if you think of the system, right, the data center or the server racks are a system that are doing some job. And if we think of the hardware, software, network layers individually, then they'll be piecewise optimized, and what we see is there's much greater optimization if you think of it jointly. We see that happening with neural nets and hardware and everything. There are some examples. SysML is a machine learning conference that I think Stanford puts on, and they've now really focused on sort of a system level joint optimization of software, algorithms, and the hardware. Another example that's been around for quite some time is MobileCom. That's sort of a mobile device or mobile computation communications oriented conference. But again, it's really now heavily focused on hardware, software, and, well, not network in the wire sense, but network in the wireless sense, communications. And so that whole stack is really what we could see more of.
Okay, thank you. James?
Yeah, one thing that's of interest, I think Rick called it the valley of death earlier for startups, where data centers, you're deploying hardware at very large scale. And it's hard for startups to play a role. So you have academic institutions that can do the research which is necessary on these type of development timeframes, and you can have large established companies that can bring hardware to production at scale in the needed time frame. And there's this gap. How do you start a system for data centers? And what's the right way to engage them? And as a community, can we figure out a better way to engage them in hardware development at the DC scale?
Thank you, James. So we are ready to wrap up our discussion. And before we finish, I would like to say that we are open to get the questions from the audience. I would like to thank Rick, James, and Yuri for your participation and for your time. I really appreciate that. The discussion was really great. Thank you so much. And hope to see you on the next event. Thank you.
Hi, this is Lisa here, and thank you so much for joining the industry investment panel. So we had James from Facebook and Rick from M12 at Microsoft online, and we are ready to take your questions and answer them. So my first question would go to Rick. Taking into account the current context of the pandemic and the economic downturn, where should we focus our attention and where the short-term investment should go?
Yeah, if I keep this to data centers, hi. I guess we did the introduction. So with the pandemic, I mean, there's short-term needs and opportunities, and I think each of us on this call are seeing that pain, and that's just how do we keep scaling out quickly enough and robustly enough to maintain all the new throughput and capacity that we have to deliver. I mean, so many folks have moved to the cloud, you see video conferencing, you see these online platforms. So to me, that's a short-term kind of, okay, can the suppliers put it all in place? Can we innovate around making what we have more efficient? From an investment standpoint, again, those payoffs are in 2 to 5 years, of course. And I think they're the opportunities, I think are the usual ones, but we also have new workloads that are, I'm really excited to see happening with this COVID thing. And trying to find therapies, trying to find how we attack pathogens like coronavirus. The computational workloads now are just going up tremendously when you want to simulate these proteins, when you want to simulate compounds to come up with therapies, cures, and preventatives. So those become opportunities now. How do we use computational chemistry, computational biology, computational materials now, where you're simulating these things in the cloud or a data center with maybe hundreds to thousands times more computation than we've used in the past for these things. So exciting area that I'm tracking quite closely right now.
Yeah. So we also had a question from Salim and Mark, who asked about the cases of enterprise adoption of OCP beyond the hyperscale as Facebook and Microsoft. James, can you maybe give us some examples of those?
Well, I think the open hardware model could work beyond the mega data centers. And I think initially this is what's expected, is that the adoption would primarily come from the mega DCs. But we do expect over time the adoption to spread down into the enterprise as well. There's typically a burden. A lot of the hardware defined in this open environment is kind of a gray box, and companies have to put their own software on top of that. But as OCP matures, they're also coming up with software solutions that can make this more accessible to enterprise users. So I think it's a matter of time as this starts to trickle down from the mega DCs to the smaller DCs to the enterprise.
Okay, thank you so much. We also had a question from Robert, who was asking about the neutral network hardware accelerator. So how important it can be for the OCP community, and at which stage is the development right now? James?
Sorry, Lisa, for a what? A network hardware accelerator?
Neutral network hardware accelerator.
Yeah, I'm sorry, I'm not familiar with that.
Okay, yeah. So let's move to another.
This is Rick. I'm not familiar with that one either. Yeah. Sure.
Question. So what's your view on the optical artificial intelligence chip from short term as well in the long term? Do you have some ideas how that can be implemented?
James, do you want to take that one, or shall I address that?
Yeah, Rick, why don't you address that?
Okay, so I think the question was about optical neural networking, Lesia. I'm not hearing you, but I'll just go ahead and keep talking. Hopefully the mic is still live. I think the question, there's also been some discussion in the chat window about can we use photonics or optics for optical neural network type applications, and I think the answer is yes. We're seeing research in that area. There's some well-known startups that are working on facets of that. I think there are two parts and maybe to succinctly try to summarize it. One direction is really to try to speed up things like matrix multiply or vector matrix multiplication, through optical interference or some other kind of interaction of coherent light beams. And in that, you're basically speeding up matrix multiply, which is guess what? That's AI. That's neural networks to some extent. And the challenge there, I would say, for any startup, when you come speak to an investor like someone like myself in M12, it's really, you have to show an end-to-end improvement. That means that you've got data input, data output, and that whole flow, not just the inner product, but the whole flow of multiplying, a huge matrix together has to be lower energy by a big factor and faster by a big factor compared to the incumbents. And at least currently, when you look at the end-to-end flow, laser beams can multiply in femtoseconds, picoseconds. But if you look at all the electronics around it that you need to implement a system, it might only be 2 to 4 times better than, silicon from 2 years ago, a GPU from 2 years ago. So I would encourage folks to look at that end-to-end energy consumption. The next part is optical AI or photonic based AI, and that's a whole different thing where you actually use waveguides themselves to let photons through, and then you're now sort of doing spiking neural nets or something. Interesting area, and I'd like to see more of that, right? It's still researchy. Let's see paths to production. I'm over. If there's any other question.
I think we are running out of time, and I would like to thank everybody for the questions. I would like to thank James and Rick for your answers. And thank you so much for being here with us. And we're ready to finish the investment panel.
Great. Thank you.
Thank you, Vincent.